To find the second transformation, we first need to show what the first transformation is like. So we're rotating 90 degrees anti-clockwise about E. So if we're rotating about E, point E is going to stay the same because it's rotating around that point. It's just not going to move. Whereas the others, they're going to move 90 degrees around this way. Easy way of thinking about rotations is taking it corner by corner. So we'll take corner C to begin with. To get from point E to corner C, I go across one to the left and then up 3. So instead of going across one to the left, if I was to rotate that around, that across one to the left, I was going to rotate that around 90 degrees. That's going to now be 1 down instead. And this upwards 3, if I was to rotate that upwards 3 by 90 degrees, instead that's going to be to the left 3. And I combine both of those together. That gives me the new point. That's going to be point C here. And if you do a similar method for point D, you get this point here. So now I can get a ruler and join up these points. This makes our job a bit easier because we can now see where we're scaling to and where we're scaling from. We can get an easy mark here just by eliminating that it can't be anything but a scale. No other kind of transformation is going to get it bigger, like so. So it must be a scale. But the harder part is knowing by what factor and from which point. Let's start with the easy corner. So obviously point E has gone to point R. The other points can cause a bit of confusion because does this one go to here or does it go up to P? It actually goes to point Q here. And this one goes to point P. Now if you were to do it the other way around, you'd see something quite strange because at the moment all of these points, all these lines are crossing at this point. If we were to switch these points over, then you can see straight away that we've done something wrong. Because these lines, they're not all going to cross at the same place anymore. So that must mean we've done something wrong. So you can see right there, it's just not very good at all. So now we know we're scaling from this point here. And we can see this, if I was to scale from this point, then the lines aren't moving. The triangle is moving away, and it's getting larger. If I was to enlarge it and get smaller, then it's going towards that. Now if this approaches 0, it's getting closer and closer and closer to that point there. Eventually it's going to be infinitely small and be at point 0. If we were going to go negative, it's going to get bigger up the other way. So this is a negative scale factor. And it's going to be a negative scale factor of 2. So negative 2. Because this side here is 2, it becomes 4. So if we took this side here of 2 and we were to times that by the scale factor of negative 2, we're going to get a length of negative 4. It's not possible to have a negative length, but negative basically tells you that it's the other way around. So we have a length of 4 going in the opposite direction. So to fully describe the second transformation, we have to say that it's an enlargement. And finally, we have to say what point that's scaling from. So that's scaling from point -1, 0.